Welcome back to another video, and if you're coming from the last video, we looked at power functions for n being equal to all sorts of different values, and we had some general rules for derivatives of pretty basic functions, but we didn't quite answer what happens if we want to take the derivative of two functions multiplied together, or a function divided by another function, and we're actually going to be finding that out in this video. So we're going to use that standard definition for a derivative, and we're going to consider some function of x being equal to a of x times b of x, and we want to know what is that derivative. So if we plug in our definition, we arrive at this here, and this kind of tells us nothing. But what we want to do is find some general formula for the product of two functions when we want to find that derivative. And we're going to have some motivation for the solution, or what we want to accomplish from the solution. And we know that if we look at this right here, this is just going to be represented as f prime of x. So what we'd like to do is somehow represent this as maybe a prime of x and then something, or b prime of x and something, or some multiplication, or in general something that looks familiar to what we've seen before for that standard definition. And if we start to look at this, we can't really factor anything out of these terms. There's nothing common. Maybe we could try to complete the square or something else for that nature. But the trick that we're going to pull out of our head here is if we had some function y is equal to x squared, notice that this is also equal to x squared plus gamma minus gamma. We have this cancellation that occurs, so it acts as if it was never there to begin with. So the method that we're going to do, we're going to add something and then subtract that something. And I don't think having the trial and error is useful to this video, so we're just going to show what you add and subtract. And that's going to be the function a, and then we have b with x plus h here. So what we're going to do is group this term right here with this term right here, have that commonized, and then we just have a x plus h minus a of x. And then if we look at the resulting terms, we can simply pull out a, so that's common, and then we have b x plus h minus b of x. Don't forget that little minus sign that's right here. And don't forget that we're taking the limit as h goes to 0 of this. So if we do that, b of x plus h, that just goes to b of x. And then what's left in this first term here is simply this. And this is the standard definition of the derivative of a. So we can write our first term, b of x, multiplied by a prime of x. And then if we consider the second term here, well, there's nothing really going on with a of x for this limit, so we can factor that out. And then if we consider the second term, remember to group in the denominator there, we simply have, by definition, the derivative of b with respect to x. So let's test this, and we're going to test this with a function that we know the derivative of. So that's going to be y being equal to x cubed. And from the power function videos, we know that the derivative of this is going to be equal to 3x squared. And maybe you're asking, how is this equal to ax times bx? And we have to get a little bit tricky here, because we need two functions multiplied together to use this product rule here. Notice here we've actually noted it out as if our functions are f of x and g of x. Typically this is actually what you'll see in textbooks more often. So rolling with the notation that you'll often see, we could say that y is equal to x squared times x. And from this, we could say that x squared is equal to f of x, and x is equal to g of x. So if we apply what we arrived at, we know that the derivative of x squared is going to be 2x. That's going to be multiplied by g of x, which is x. And we add f of x, so x squared. And that's multiplied by the derivative of g of x, and we know that that is simply going to be equal to 1. Do our derivatives match? Yes, they do. So it looks like our product rule does hold. But what if we want to look at division now? So we're going to have the derivative of some function f divided by some function g. Again, we're going to take in mind that definition for the derivative. So if we plug that in for the definition, we arrive at this kind of messy looking term here. We can simplify this to have this term here, which I guess is arguable if that's simplifying anything at all, because it looks just as awful to deal with. And maybe you're asking the mathematical wizard, what's the secret trick now? And again, I think trial and error is cumbersome. So we're just going to add and subtract the term f of x times g of x. So if we do that, we add that term, we subtract that term, and then we're going to group things as they need to be grouped. So if we do that, we simply get g of x, we get f of x plus h minus f of x, and then we have g of x plus h minus g of x, which looks pretty good here. But notice in the denominator, we still get this g of x plus h times g of x. And this looks kind of different, and maybe you're thinking you need to somehow get rid of this, but you don't. Because if you take that limit as h goes to 0, well, g of x plus h just goes to g of x. So we have g of x multiplied by g of x, so we get g of x squared. And now if we consider this on a term-by-term basis, so this first term, this g of x, could be pulled out as well. And then you would just have f of x plus h minus f of x divided by h, assuming that we pulled out this term as well. And that's just the derivative with respect to x of the function f. So that's represented here. And if we look at that second term, again, group in the denominator, you just have the derivative with respect to g, because you can pull out f of x. So what you're left with is this resulting term. And again, we can test this with a function that we know. So let's say, again, y is equal to x cubed, and this is equal to x raised to the fourth divided by x. So if we use what we had up here, we arrive at this term here. By simplification, we get 3x raised to the fourth divided by x squared, or simply 3x squared, which we know should check off from the power rule. And this is what we call the quotient rule. But we're going to investigate the quotient rule a little bit. So consider the function that we've been looking at, f of x divided by g of x, and we know what the derivative of that is going to be. And if we break that up actually into each term, what we get is f prime of x divided by g of x. But if you take that second term, you get f of x multiplied by the derivative of g of x divided by g of x squared. And it's this g of x term that looks weird compared to the product rule. So we're going to do something a little bit weird. And we're going to say that we have some function k that's a function of g of x. And that's going to be equal to 1 divided by g of x. So what we could say is our derivative before, f of x divided by g of x, is also equal to the derivative of f of x times k, where again k is that function of g of x. And we've just looked at the product rule, so let's try to use it. And what we get if we apply that product rule, so we know that we have f prime of x times k of g of x plus f of x times the derivative of k. And if we set that equal to what we know it should be, so these two terms up here, and if we express k to correlate it to that first term here, we can see that this checks off, so there's no problems there. Well, let's look at the second terms. So we have f of x multiplied by the derivative of k. And by our math, that should be equal to minus f of x times the derivative of g divided by g squared. So we can simplify this. And if we look at what the derivative of k is, well, we know that it actually has to be equal to this term here on the right. But if you just compare these two last terms, you can see something kind of weird going on. And maybe I'll leave this on a cliffhanger. So recall if we had x to the n and we took the derivative, that would go to n times x raised to the n minus 1. And notice here we have g raised to the minus 1. And right here we have minus 1 g of x. And we could say that that's raised to the minus 2. So there's something mysterious going on here. But then in addition to that, we also have the derivative of g of x tacked onto that. But we will cover that in the next video. If you learned anything new, useful, please like, comment, share, subscribe. Helps the YouTube algorithm. Thank you for watching, and we'll see you there.